Alright, another thing that's useful for us is the concept of the complement of an event A. Alright, and the complement is written as A with a bar on top of it, called A bar. Alright, and the complement means just quickly not A or everything else but A. Okay, so in other words, the complement of the head on a coin toss is tail on a coin toss. The complement of, on the roll of the dice, let's use that, a 1 is the event, either a 2 or a 3 or a 4 or a 5 or a 6 on the roll of a die. Okay, so complement is everything else but the event that you're looking at. Alright, and so in general, and in particular, the probability of A plus the probability of A bar is equal to 1. And that's because both A and A bar together make up all the events in the event space. Alright, so A head, A bar tail make up everything. Right, A being a 1 on the roll of the dice, and A bar being 2, 3, 4, 5, or 6 on the roll of the dice, make up all the events. So the probability of the two together adds up to 1. Okay, or another way of thinking about that, of course, is the probability of A, sorry, not and, but or, which leads us to a plus. A bar is equal to 1. We could do that from the addition rule since there is no overlap, or since A and A bar are mutually exclusive. Okay, and since we're talking about this, right, when we say or, we add. When we say and B, all right, and means we're going to use multiply or the multiplication rule, or add plus or the addition rule. Okay. And since we're talking about complements, we're going there so that in some problems we'll have both multiplication rule and complements, and in problems like that we can use the following table. So we'll have, say, events A and a complement A bar, event B and a complement B bar. And it doesn't matter if you have the A's and B's on this side, sorry, the A on that side, and or the other. All right, and this table would carry probabilities. All right, so in the rows down here, all right, column total under A would be the probability of A. Under A bar, probability of A bar. Across from B would be probability of B bar. B. And across from B bar would be the probability of B bar. In the midst of the table, and students often get this wrong, under the intersection of A and B is the probability of A and B. Intersection of A bar and B will be the probability A bar and B. Okay, and then here will be A and B bar, and finally A bar and B bar. Okay, as I said, this table is quite useful. By the way, notice that with these complements, I can say that the probability of A and B bar using the template of the multiplication rule would be equal to, say, either probability of A times the probability of the other event B bar given the first event A, or rearranging, all right, B bar first and A bar second, which is the same thing, would be a probability of B bar times the probability of A conditioned on the first event B bar. Okay. Just as in certain problems you might be given two events X and Y, so you can say the probability of X and Y is equal to, again, the first event X times the probability of the second event Y conditioned on the first event X. Okay, they're just general rules. All right, let's now look at the following question that involves events A and B and complements and conditions and joint probabilities like A and B. Okay, and we can use the table that we just introduced to answer all of these questions.